Chapter 2 by discussing inductive reasoning and then eventually deductive reasoning, and this is the bottom of page 13 in your packet. So we talk about what it means to use inductive reasoning to make a conclusion. So when we're making conjectures, we're using inductive reasoning. Which is a type of reasoning where you use patterns or observations and different examples to form a conclusion, which we call a conjecture. So a conclusion. In example 1, we see that you're given a sequence of numbers and they want you to make a conjecture as to how to get to the next number. So we see a pattern in which it's 1, 3, 9, 27, 81. We've seen these types of questions since grade school. In this case, we would say that our conjecture is that the previous number, that hashtag symbol I'm going to use in this class as number, is being multiplied by 3. In example 2, we have a series of square figures and they want to know, how do we get from the previous figure to the next figure? So I see that this is a 1 by 1 square, a 2 by 2, a 3 by 3. So it appears as though each side is increased by 1 to get from one to the next. Now we're going to have you guys try a little bit on your own with play pause it here. You're writing a conjecture that describes the pattern in each sequence. That I'll right after you guys come up with the next term, but you're going to use that conjecture to find the next term. So you're going to make an observation about the first 4 terms in the first problem and tell me what you think the next term is. And the pattern or conjecture here is each previous number is being multiplied by 2 to get from one to the next. Actually, if we examine it a little bit closer, by 2 would not get us, -5 times 2 would not work because that would get us -10. So it's in fact by -2. Now I'd like you to figure out the next term you think would come in number 2. And if you said the conclusion was that each previous number is added by a 5th to get to the next one, then you were correct. For 3, we'll do this together. This is a famous sequence called a Fibonacci sequence. So you might have seen this sequence before in a previous math class or science class. It will be examined a little bit more in your advanced classes, but in this case, I'm noticing that the pattern isn't just adding or multiplying or dividing or subtracting the previous number by a constant number. So take a look at it, see if you guys can figure out what's going on. Good if you guys determine that the next number is the sum of the previous 2. So 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. So on and so forth. So our next term in this sequence would be the sum of the previous 2 terms, which would give us 21. Now below here's a few geometric relationships where we're going to write a conjecture about the given information. So our first task is make a conjecture about the sum of 2 odd numbers. So what I'd like you to do is think for a moment what happens when you add 2 numbers that are odd. So 1 plus 3, 3 plus 5. And what type of conclusion can you draw about the answer that you get each time that you add 2 numbers that are odd? 101 plus 103. Okay, so our conjecture will be that our solution always is even. And we see that after we do a few examples here. And we're observing the examples to then make a conjecture. So On 4, they want us to write a conjecture about this statement. Angle ABC and angle DBE are vertical angles. So think back to what we learned in the previous lessons. If two angles are vertical angles, what conclusion can we draw? What conjecture can we make? They are congruent. Good. Okay, so angle